Good morning, boys. How are you? Today our lesson is solving compound inequalities. Compound inequalities mean we are going to combine two inequalities. Before we start, as usual, we have some slides as revision for the previous lesson. Solve 3x minus 15 less than 45. Of course, here with the variable x, I have subtraction and multiplication. As I told you before, always try to get rid of the easy operation. Here I will get rid of negative 15 by making plus 15 plus 15. You will get 3x equals 60. Then you will divide on 3, divide 3, divide 3, you will get x less than 20. Another example, the same. Here we have variables on both sides. 2p, 4p. Get rid of the smallest variable, minus 2b, minus 2p. You will get negative 22 more or equal 2p plus 14. Then minus 14 here, minus 14 here. And complete, you will get the answer, p less or equal negative 18. Here also another example, the same way. But here, the variable x is divided by 4. After I get rid of negative 3 by making plus 3 plus 3, you will get negative x over 4 less than 16. Of course, here we have negative. Therefore, when I multiply because I have division. Opposite of division is multiplication. Because I have negative, I will multiply by negative 4. When we multiply or divide by negative number, we must flip the inequality. Therefore, here the answer will get x more than negative 64. Here, I will make distributive. 2 multiply the brackets. This means I will multiply 2 by n and by negative 5. 2 times n to n. 2 times negative 5, negative 10. You will get 2n minus 10 more than 7. Then you complete, solve in the same way. Here also the same. I have brackets in both sides. Here I will multiply 8 by 6 and negative 8. And here I will multiply this negative by negative 3k. Then you complete in the same way. After you multiply here, you have here variable k and here variable k. You must make simplification. And you complete, you will get k less or equal 7. Now we go to our new lesson, which is solving compound inequalities. The new vocab in this lesson is compound inequalities. Compound inequalities, this means you will have two inequalities. You will solve them by each other. The compound inequality has two kinds, intersection and union. Intersection, we combine the two inequalities using AND. Union, we will combine the two inequalities using OR. And of course, we will study them in details. Solve 7 less than z plus 2 less or equal 11. Here, as you can notice, we have three sides. Z plus 2 more than 7 and z plus 2 less or equal 11. This kind or this inequality is intersection. Here we can separate or we can make this inequality two inequalities and we can combine them using AND. I can change this to 7 less than z plus 2 and z plus 2 less or equal 11. You see? You can write this one like this exactly. This compound inequalities, I make it two inequalities. Z plus 2 more than 7, Z plus 2 less or equal 11. Of course, boys, only when we have AND we can write the inequality like this. When we have OR, the two inequalities will be separated, direct. He gives me the inequality separated, each one alone. But when we have and, he can write it like this in one inequality, or he can separate them by using and. Of course, now after I have this, what I do, I solve each one alone. I solve this alone and this alone. Here I make -2, -2, you will get z more than 5. Here also -2, -2, you will get z less or equal 9. Now z more than 5 and z less or equal 9. This means here the solution is limited. Why is limited? Because z or z take the values which is more than 5 and less than 9. This means it can be 6, 7, 8, and 9. Why I say and 9? Because z less or equal 9. This means it can be 9. But can z be 5? No, because z more than 5. The solution set or the group is z more than 5, less or equal 9. As I said, it's the number 6, 7, 8, 9. Therefore, when I graph them, I will get segment like here. Pay attention. You see? Here to graph them, boys, I graph each inequality alone. Graph z more than 5 or z more than 5, this one. Of course, here over 5, I put empty circle because I don't have equal. Z more than 5, then I go to the right. I graph this in one line. Then I draw another line under it to graph z less or equal 9. Less or equal 9, this means the circle is solid. Less or equal, I go to the left. Now, I must take the intersection between the two graphs. You see, you draw a line like this and line like this. This will be the solution. The solution is from 5 to 9. Of course, 5, empty circle, this means it is not solution. The solution, as I said, is 6, 7, 8, and 9. This is the solution. Clear, boys? Again, I repeat how you graph. You graph each inequality alone. You draw number line and graph the first inequality. Then under it, you draw another line and you graph the second inequality. Then you make the intersection like this. From the solution, first solution, you draw line to the second number line, and the same here. You find that this part only is the intersection between the first line and the second line. It will be like this. Of course, you can graph it direct, boys, in one line. How? In one line, you draw one line and you put the two solutions, 5 and 9. Then you draw from 5, z more than 5, you go to the right. Here, z less or equal 9. From 9, you go to the left. You find that the two lines from 5 and from 9, they are in the same direction. Therefore, they make line segment. It has a start and end.